Assalamualaikum and hi. We are from CDCS 1431B. Today, we are doing our presentation for our assessment for geometry about application of geometry. Now, I'm going to introduce you about the introduction of geometry. Geometry, originating from ancient Greek words meaning earth measurement, is the branch of mathematics concerned with the properties, relationships, and the measurement of points. It roots back to the ancient civilization such as Egyptian and Babylonians, who used geometric principles for practical purposes for land, surveying, and construction. Over time, geometry has evolved through contribution from Islamic mathematicians during the Middle Ages. As for example, when we look at buildings, the shapes and structures we all see are part of geometry. This subject is not just about drawing, it involves solving problems and understanding how different shapes relate to each other. In geometry, we learn about different types of shapes like triangle, circles, and square, how to measure their areas and perimeters. We also explore three-dimensional shapes like cubes and spheres. Understanding geometry helps us in everyday life, from designing buildings to creating arts and even in sports. Now we are moving on to our cases. We have chosen two cases, which is drink container and the sphere from Las Vegas.
Now we are moving to history of drink container. First, ancient beginnings. Early civilizations used clay pots and amphorae to store and serve liquids like water, wine, and juice. These containers were essential for communal consumption and easy transportation of beverage. Second, advancements in materials. With the advent of glass and metal, containers evolved to include spots or tabs for easier serving. For design features, the balang air typically has a cylindrical shape with a clear body to display the beverage. Brightly coloured lids and vases, often red, yellow or black, make them easily recognizable and festive. Number 5. Cultural significance. These beverage dispensers are closely tied to Malaysian food culture, often used to serve drinks like syrup-based beverage, cendol or iced tea. Modern day use. The balang air remains a popular and iconic tool in Southeast Asia, symbolizing both practicality and the vibrant food culture of the region. Next problem segments. Rusdi has an upcoming marathon event which has almost 1,000 participants join. He plans to give up drinks for all the participants. He has a cylindrical water container that has a circumference of 90.04 cm and height of 57.33 cm. Find the radius of the water container. How much volume of water can he fill in one container? Rusdi has 3 cup size which have heights of 10.06 cm, 11.52 cm, 13.66 cm and a radius of 2.52 cm, 2.88 cm, 3.41 cm. Which cup has the most efficient size to prevent waste and still meet the prerequisites of satisfying 1,000 participants?
Okay, moving on into the calculation, we need to find the radius of the water container. From the information that has been given, which is circumference 90.04 cm and height 57.33 cm. We will use the formula of circumference, which is C equals to 2 pi r. Substitute the circumference into the formula, which is 90.04 equals to 2 pi r. So, radius equals to 90.04 divided by 2 pi, which will get r equals to 14.33 cm. Next, how much volume of water can Rusdi fill in one container? So, we will use the formula of volume for cylinder, which is pi r square h. For the radius, we have 14.33 cm and height 57.33 cm. Substitute the radius and height, we will get 36,984.88 cm cube, which is 37 liters. Next, Rusdi has 3 cup sizes which have heights of 10.06 cm, 11.52 cm, 13.66 cm and radii of 2.52, 2.88 and 3.41 cm. Now, which cup has the most efficient size to prevent waste and still meet the prerequisites of satisfying 1,000 participants? First, we need to find the volume of all 3 types of cup. For the first cup, pi times 2.52 square times 10.06, which is the radius and the height. We will get 200.01 cm cube, which is equivalent to 200 milliliters. Same goes to the second cup, pi times 2.88 square times 11.52 equals to 300.18 cm cube, which is 300 milliliters. The last cup, pi times 3.41 square times 13.66, which will get 499.01 cube, which is 499 milliliters. So now we have all of the information that can be used to determine which cup is most efficient. For the first cup, we use the volume of the cylindrical tank divided by the volume of the cup, which we will get 184.28 cm cube, which is equivalent to about 184 cups. Same goes to the second cup. We divided the volume of the tank and the cups, we will get about 123.21, which is about 123 cups. And then next, the cup number 3 will use the same formula too, which we will get about 74.12, which is 74 cups. Next, we have how much cups do we get for one container. We need to find how much container can we get for thousands participants. Now, for the first cup, we use thousands divided by the total of cup that can we get from each cup, which is 184 for the first cup. We will get for about 5.43, which is equivalent to 6 containers. Now, the next cup, thousands divided by 123 equals to 8.13, which is about 9 containers, or even 9 or 8, but preferable that we choose 9 containers. Now, for the third cup, thousands divided by 74 equals to 13.51, which is about 14 containers. In conclusion, we will use cup 1. The reason is we will be only using 6 containers and can get to 1,000 cups and has an extra just a bit.
Next, we're moving on to the history of Sphere in Las Vegas. For the development and construction, it was conceived by James Dolan, Executive Chair of Madison Square Garden. It was announced in 2018 in collaboration with the Madison Square Garden Company and Las Vegas Sands Corporation. Its design is created by the architectural firm Populous. The construction of the Sphere started during September 2018. It finally held the grand opening at September 29th of 2023. It stands at around 366 feet tall with a width of 560 feet. The exterior of the Sphere holds 580,000 square feet of LED displays capable of showing a billion colors. Meanwhile, the interior of the Sphere has 16K resolution wrapped-around LED screen. It is equipped with an advanced audio with beamforming and wave field synthesis. It also has 4D effects, such as scent and wind, and haptic technology in 10,000 seats. For future plans, it will be a staple to hold live sporting events. It will be upgraded with further audio and video enhancements, and will have 24-hour live streaming options. One of the reception and influence of the Sphere was its cultural significance. It quickly became a must-see Las Vegas attraction. It was praised for immersive and innovative entertainment experiences. Long-term vision for the Sphere continues to inspire advancement in live entertainment technology and global venue designs. Going on to the problem statements for this case, a service company for the Las Vegas Sphere is trying to change the LED board for the whole Sphere. The building is in the shape of 3/4 sphere. The Sphere has a radius of 78.5 meters. Find the surface area of the Sphere. They decided to change the shape of the LED board from square shape to either triangular shape or hexagon shape board. The length and width for the square shape is both 0.5 meters, while the triangular shape has a base of 0.8 meters and height of 1.0 meter. The hexagon shape has a side length of 0.439 meters and a diameter of 0.878 meters. Which shaped LED panel will be used the least to cover the whole Sphere? If the triangular shape panel is RM3000 per piece and the hexagonal shape panel is 4000 per piece, which shape LED panel is the cheapest to use?
Okay guys, now we move to the calculation of the Sphere of Las Vegas. So the first question is, find the surface area of the Sphere. So the information given is radius 78.5 meter and the building is 3/4 of the whole Sphere. So we can use the surface area of Sphere formula, which is 4 pi r square, and calculate the surface area of the
Las Vegas sphere. So the surface area is 3/4 times 4 pi r square equals to 3 pi r square. So with the radius given, we can substitute into that formula, equals to 57,972.5 meters square. So for the second question, which shape LED panel will be used the least to cover the whole sphere? So the information given is the length and width for square shape is both 0.5 meter. The triangular shape has a base of 0.8 meter and height of 1.0 meter, and the hexagon shape has a diameter of 0.87. So for the first panel is square panel, the formula is length times width equals to 0.5 times 0.5, and we get answer 0.25 meter square. So for the second LED panel is triangular panel. So for the area formula of triangle, we can use 1/2 times base times height. The area of triangular panel, which is 0.4 meter square. So for the last panel, we need to use formula of polygon, which is 1/2 times n times r square sin 360 over n. So with the information given, the hexagon panel is 0.878. So we need to find the radius of the hexagonal panel, which is 0.878 divided by 2 equals to 0.39 meter. So we insert all the information that we have into that formula, equals to 1/2 times 6 times 0.439 square times sin 360 divided by 6 equals to 0.5 meter square. The last step is we need to calculate the number of panel needed for the sphere of Las Vegas. So to cover the entire surface area of the sphere is total surface area of sphere divided by area of one panel. So for the first panel, which is square panel, 57,972.5 divided by 0.25, and we got 31,890 panels. For the second panels, which is triangular panels, and we got 144,932 panels. And for the last panels, which is hexagon, with the same method, 116,195 panels. Okay, so for the last question, if the triangular shaped panel is 3,000 ringgit per piece and the hexagonal shaped panel is 4,000 ringgit per piece, which shape LED panel is the cheapest to use? To calculate total cost for triangular and hexagonal panels, we need to times the numbers of LED panels that we need with the price of the panel. So for the first panels, which is triangular panels, we have 144,932 panels times with 3,000 ringgit. So the total cost for triangular panels is 434,796,000 ringgit. So for the second panels, which is hexagonal panels, the price is 4,000 ringgit per piece. So we times with the number of panels, 116,195 panels times with 4,000 ringgit. So we get the answer 464,780,000 ringgit. Best option to find the cheapest LED panels to use. So in this case, the triangular panels is the cheapest option. Okay, now we move to the recommendation. So with the surface area and the volume, we can use it in engineering and product design. So for the volume, we can use to determine the capacity of tanks, water bottles or storage containers. For example, engineers can calculate the volume of water tank to ensure it meets daily consumption needs. For the surface area, important in designing machine or devices, as the surface area impacts cooling system of the amount of material needed for coating, such as paint or insulation. For the second is construction and architecture. The volume essential for calculating the amount of materials like concrete, soil or water required for construction project. For the surface area, it used to determine the amount of finishing materials such as paint, tiles or flooring required for walls, ceilings or floors.